So Snort is kind of similar to Wireshark, I think, in that it can analyze packets and you can log packets. But what the main difference is between the two is it sits in line and it can actually, you know, display alerts, and it can be used as an IDS and IPS. So with Wireshark, we're just analyzing packets, but with Snort, you're analyzing packets as well as you know doing something with those packets. Getting detections of the packet, and you're also preventing uh, malicious activity based on predefined rules that we've set. So this room in TryHackMe is basically uh, we're going to write IDS rules. I have done some research and I did find that this rule is kind of messed up in that the answers that you provide sometimes do not show the right answer. But anyway, we'll figure it out. So there's exercise files. The first one I'm going to do is HTTP task 2. So all right. So we're gonna do task 2. So I'm gonna go to task 2. All right. So in order to make a rule, I'm gonna have to like kind of similar to making a script. So hold on before I do that. Let's just make sure. So yeah. So apparently there's two ways that I can do this. I can create the rule first and then analyze the packet based on the rules that I've configured, or I can, you know, open up the file and scan it based on the rules. So I'm gonna see how we can do this. So okay, so we're gonna do sudo. We're gonna call it local rules. So let's see. There's like a stand. 480 is being bound. And the message can be HTTP packet from maybe SID security identifier. When a user logs into a computer, their user SID and privileges. Well, we're using it to kind of identify this particular rule. SID is going to be one. And then second one is going to be same thing. But this time it's going to be outbound. So any port 80. Messages will be same thing. That to should be the second. We'll close that out. Okay, so now that we have created our rule, we can now analyze this particular packet. So I created a rule in the local.rules folder. So now I'm going to go ahead and try to analyze it. So there's SNORT -c local.rules, and then -dev, so it can that makes it go to a log file, -l, and then a dot. I'm not sure what that dot means, but I know we're gonna do -r, and then this is the name of the file, the packet we're gonna capture. So it's gonna be mx-3.pcap. So basically, the first thing is we cd'd into this tasks folder, and now that we're in the folder, or in the directory rather, we were able to create the rule. And now that we created the rule, this is the rule here that we created, and it's going to be showing us a log file, and this is the file that we're analyzing, the packet we're analyzing. So it's saying unknown rule. Let's try that one more time. All right, so let's go back to all right, let's see what's going on. So apparently something's is any. All right, I think let me see if I can edit. Let's see. All right, so after I edited that name, we were able to get the all of the packet information based on HTTP traffic. So we scroll down here. This is pretty much what we're looking for. So they allowed 460 packets of HTTP, and there were 164 alerts. So if we go here, I think if we, so yeah, these were just created today. So snort log. Okay, I guess I can't open that, but I know alert is pretty much the same thing that the alert is pretty much the alerts that it found. HTTP packet found, and you can see it's port 80. So based on the alert that we created, it gave us those alerts. And if I was a security analyst, I could pretty much sift through these and find what information I'm looking for. Maybe it's a particular IP address that I'm looking for or something like that. But these is all on port 80. I mean, it's a lot of information to look through. It's a lot of stuff going on here, but it's port 80 it's pretty much picking up off of. So basically all I had to do was going back here to the thing. See if I can go back to the top. So basically, yeah, it's a lot. So, but anyway, so we had to create that script and then ran it based on the alerts, and then we were able to go here and see the alert. And local rules. This is the local rule that we created, which was pretty much alert TCP from any IP address from any port to any on port 80, and it will display the message HTTP packet found. I could have changed that to anything HTTP packet, something like that, but I did that, and now it's here. So this is the information that we needed to do to get HTTP packets based on a rule. So now I'm going to try to answer the question. Like I said, I did read some stuff saying that it was the questions were incorrect. So what is the destination? Well, sorry, you must answer this question. What is the number of detected packets? So I'm going to go back here. And I'm going to go to alerts, and actually I want to go back to the command, to the terminal to actually see. So there was 164. alerts that were logged. So actually, detected packets would be yeah. So I mean, clearly there's something going on with the room, but because we can see that there's 164 alerts that were logged, but it's not showing us here. But either way, we know 164 is obviously correct. So we can move on and investigate the log file. So the log file is here. And what is the SEQ number of, okay, sorry, I skipped. What is the destination address of packet 63? The destination address of packet 63. So if I go to packet, let's see if we can find. So we're trying to find the packet, not the packet. We're trying to find the destination address of packet 63. So where's the packet? You know, obviously it's gonna have a destination and a source address. So we're gonna try to look for packet 63. That's like the first thing, and then for packet 63. There's a way that I can. Okay, so I'm gonna have to look at the log file actually. So these are the alerts. Okay, so if I wanted to pretty much snort a specific log file, I would have to do it differently. The power of Google showed me that, so I have to do snort minus R, and then snort. All right, so I'm gonna have to snort that log file. Snort minus R, snort dot log dot 64. Actually, 65. 4 374. And this particular question was asking for what's the destination address of packet 63. So we can do 63. Permission denied. So I think I need to do sudo. Yeah. So let's look for the destination. And that's so if I look here, so it's most likely source, destination. Actually, destination and source. Let's see. All right, so at least we know it's going to be like 3 digits for each one. So I most likely it's going to be that 145254, which does make sense. So destination and the source is 65, and obviously, and it's still port 80. You see it right there. That is okay. Let's try it again. All right. Investigate the log file. What is that acknowledge number of packet 64? Let's see. What's my last? So this is for packet 64. Let's see. So we do see here there's a acknowledge, um, and then like I was saying before, it's still something obviously is wrong with this because I don't think it's gonna go through yet. So the person who made the room did not obviously do the correct answers, or maybe they did it on a different file and they did not like update it to the certain cell, which does make sense. But anyway, investigate the log file. What is the SEQ number? Sequence. So let's look what packet analysis. What does that mean? Sequence number. So if we look at our chart here, we have a client and a server. So the client is obviously going to reach out to the server. It's going to give an acknowledge number, sequence number. So that looks like the sequence number is like the acknowledge number. And it's just like until the session closes, until the TCP closes. So that's the sequence number. So for the sequence number, it's going to be, and this, I believe this is still for the same packet for packet number 62. So like once we answer that first question, it's pretty easy to do the other one. So 62. Let's see. We get this answer here. Oh, interesting. There's so many of them. There's different ones too. 6, 38. That's interesting. But I'm asking specifically for number 63, 62. All right. See if Yeah, it's still not gonna. All right, so the next question: investigate the log file. So we're still investigating that same log file. And what is the TTL of packet 65? I believe TTL is time to live. Let's see. Time to live is a value for the period of time that a packet or data should exist on a computer or network before being discarded. Depends on the context. So the TTL of packet 65. So first off, let's see, how do we find the TTL? It's here. So usually it's there. Everything is here. So it says packet 65. $128. Let's see if that one goes through. Okay, so it looks like some of them go through and some of them just don't work. So, what is the source IP of packet 65? Same packet, so we can look. See that it is. Okay, so source, destination. Source is going to be this 145.237. Right. So let's paste that there. Let's see if that gives us. All right. What is the source port of packet 65? What's the source port? It's 3372. Distributed challenge coordinator using Microsoft Transit processing technology. Okay, so 3372. All right. So this was a pretty much I was able to create a rule. I was able to create a rule, and this is the rule here. It was pretty much to alert whenever there was HTTP packet was found, inbound and outbound, and on any port. So once I created that rule, I was able to snort out the log file that is on our desktop for task 2, and then we got the alerts. So here are the alerts. And if you can remember on the command, in the rule, actually, I also was able to get it to come to a log file. So now that I created the rule, HTTP traffic has now been snorted out successfully for this room.